What's up, everybody? This is Ryan here, and you're watching video number 7 of my Android 2019 tutorial playlist. So in this video, we're going to be looking at wiring up the ViewModel, and in the previous video, number 6, basically we'll be writing the ViewModel that we hooked our fragment up to. So if you're curious about how to actually write the fragment that this particular ViewModel is going to publish events to, or data to, then you'll want to go back and watch that video first. Now, once again, before I proceed, if you haven't already watched video number 2, where I go into detail about the Model-View-ViewModel architecture on Android, you might want to watch that first. And the reason why is it's important you understand that there's a couple different ways to do the interaction between the fragment and the view model, or the view and the view model in general. And the approach we're going to be taking today is basically good in a situation where you don't need to reuse your view model, and you would prefer to have a fairly simple view which doesn't have a whole lot of logic. So basically, like I explained in detail in that video, what we'll be doing today is we'll write a view model which basically allows us to pull pretty much almost all of the presentation logic of the fragment, the view, out of the view. And the good thing about this approach is that we can still maintain the Model-View-ViewModel pattern by communicating with the fragment only through LiveData objects. So like I said in the previous video, you can also use data binding, but today we're just going to be using LiveData to communicate between the view model and the fragment. Alright, so before we proceed, you may want to grab the repository or the code that we'll be working with today, link down in the description box below, and you're going to want to either clone or download that particular project and pull it up in Android Studio or whatever is your preferred IDE. Anyways, before we get to the specific view model that we'll be writing today, I wanted to show you the abstract class called BaseViewModel, which the view model that we'll be writing extends. So we're not actually going to write this class out, but what I wanted to do is basically just talk about it really briefly and what it does for us. So there's a couple different options for extending the functionality of existing sources in Kotlin, and when we want a really object-oriented solution, one of the best ways to do that is with an abstract class. So the purpose of this BaseViewModel class is basically anything that is going to be common to basically every view model in this application. I want to include that in the abstract class. So if you'd like a detailed explanation of this kind of thing, I do go into detail about all kinds of different things, including how to achieve similar behavior with extension functions in my Kotlin course, link in the description box down below. So do consider checking that out. Anyways, what we're looking at here is our BaseViewModel class basically is going to be containing a coroutine context object, and it extends, of course, ViewModel from architecture components, and then it also extends coroutine scope. So the reason why I wanted to bring this up is it's important you understand that this is how or where we're going to kind of launch our coroutines from. Now, I'm not actually going to go into detail on coroutines in this particular video. I will go into more detail in another video in this series, but just understand that when we look at a particular view model, so for example, we have our coroutine scope set up in this class, and then we have our coroutine context down here, and just notice it's going to be basically placed on the UI context, Dispatchers.mainThread, and then we have our job tracker object, which allows for cancellation functionality. So when I open up a particular view model, which basically, that's not a view model, good job, Ryan. When I open up a particular view model which extends our base view model, just understand that every time we're making this launch builder here, it's going to be an extension on our root coroutine scope. So anyways, I'm not going to go into more detail on that in this video, but I will talk about that in detail in another video. And I just wanted to mention it here in case you're wondering, why is the launch thing all yellow here? That basically means that it's an extension on our view model. So one other thing I would like to mention, so the thing about working with this view model is obviously our LiveData objects have to be publicly visible, but since we're not returning LiveData objects from the backend, we have to work with mutable LiveData. So one suggestion from Al Warren, who's been a really awesome contributor to the WiseAss Slack channel, he just mentioned that one of the ways you can kind of get around this issue of having a publicly visible mutable LiveData object is to basically make the LiveData field, which is publicly visible, or the LiveData reference rather, you basically make the actual data, the actual mutable LiveData object, as what you would maybe call an implicit backing field in technical language. But basically what we're talking about here is this thing here, the error state, which is the mutable object, and we'll see a couple different examples of this. We can kind of hide those behind, the mutable LiveData reference behind a immutable LiveData publicly visible reference. So basically what I'm saying here is if you want to improve your encapsulation, then do consider taking this particular approach here. All right, so the class we'll be writing today is user-view-model. So there's kind of two ways you can do this. So I'm assuming you've downloaded or cloned the repository, or you can just watch if you like. But you can either basically just delete everything in here except for the package statement up top, or you can just create a new file, maybe call it login-view-model, and build them kind of side by side, whichever you prefer. Today what I'm going to do is I'm going to just actually select everything here and delete it. Now before I do that, I just want to mention very briefly, one thing we're not going to code today in this particular view model is the onSigninResult function. Now the reason for that is that I'm going to be covering that in the part of this tutorial where we discuss using Firebase and Google Sign-In Provider. Anyways, with that being said, I'm just going to delete everything there. Maybe I'll leave this comment up top just for the fun of things. And we can get started building our view model. So the first thing we'll do is we'll build out our class declaration. So we're going to type class login view model. Actually, sorry, user view model. Probably should have picked a better name for it. So we've got login view model, and this thing is going to extend our base view model class. Now, when we extend the base view model, if I just hop back to it really quickly, we have this function here, abstract fun handleEvent, and then we also have what's known as a generic type. So basically what this is all about is that T is going to be some kind of sealed class which represents different events which can propagate from the user interface. So we won't write that particular class, but I'll just show you what it is in this particular case. So it's going to be a login event class. Let me actually just pull that sealed class up so you know what's going on. So we've got login event. And so yeah, as you can see, just a pretty run-of-the-mill sealed class here. Now, one of the things to mention is that we, in some cases, will be returning this login result class here. So that's just basically like a data wrapper, essentially. So it just maintains a request code and a user token. So this is the stuff which we'll be dealing with in the Firebase video. But again, since we're kind of using it in this particular tutorial, I just wanted to briefly mention what it is. So we've got not too many different events here, just the three. So there's onAuthButtonClick, onStart, and onGoogle sign-in result. And these are all events. If I open up, so this is going to be fragment login. So that's basically all the events for this particular layout here. Back to our user view model. All right, so we have our login event class, and because we have that one type in here, we do need to supply a particular type for our sealed class. So that one is going to be a login result, like so. And then we need our constructor, or initializer, I think it's actually called. And that's not all though, so I'm just going to give our curly brackets here. So BaseViewModel is expecting a coroutine context object. So what we're going to do is we're going to basically pass in a reference here called UI context, which is going to extend coroutine context. And so that's going to get passed into our view model here. So in our base view model here, that's going to get passed in. So during testing, we would basically want to mock or fake this particular object and return Dispatchers.unconfined. but when the application is actually deployed, then this is going to be basically running on the main thread, or rather our coroutine scope will be scoped to the main thread. Anyways, back to our user view model. All right, so we've got our UI context object. So what we need to do is we don't actually want to hold on to this thing in our actual view model. We just want to pass that thing to the superclass here, the BaseViewModel class. So I'm just going to type UI context, and that should satisfy that particular error. And now it's going to scream at us because we need to implement our handleEvent function. So I'm going to click on that, hit Alt-Enter, and then implement members, handleEvent. And there we have our handleEvent class with the appropriate sealed class accompanying it. All right, now there's one more thing we need to do with our constructor. So the way that we actually get data basically in and out of this particular view model is through a repository. Again, I will go into more detail on this in its own particular video in this series. But what we're going to do is we're going to type val repo, and that's going to be of type iUser repository. All right, so we'll actually get to coding our handleEvent function a little bit later. What I wanted to start with here is the various view model objects, or sorry, the various mutable live data objects that we'll need to be working with. So let me write one out here, and then we'll talk about how this kind of works. So the first one we're going to write is the actual data model which this particular view model holds on to. And we are going to make that one private because I don't want that one to be tampered with whatsoever, except for within this particular view model class. So we're going to type private val user state, and that's going to equal mutable live data, and the type is going to be user. So if you're not familiar with live data, so basically how this works is it's going to pretty much wrap some kind of object. It could be a string. In this case, it's the user data model. I'll just open that up really quickly here. And it's just like a really simple data class which has a UID and a name. So this mutable live data is going to basically wrap that object. It's complaining because I need to add that. And then that's how we'll actually kind of persist the data in this view model. Now, some of you might be wondering what's the difference between mutable live data and live data, and when should you use them? So I would basically put it like this. Live data is essentially an immutable class. So basically what that means is that you can't change a live data object sort of within the class that's holding it. So what you can do is, let's say hypothetically we were actually working with a user data model, which was coming in from a backend tool like, say, Room. So the important thing to know here is if we were returning a live data object from the backend, then you would want to make this live data. But in this particular case, since we're returning an object, just the user object, which isn't a live data object, that means we need to make our live data mutable. So this basically means, as you'll see in a moment, that we can actually, from within this class, change the particular value that our mutable live data object wraps. Okay, so we've made our actual data model wrapped by a mutable live data object. And then what we need to do is we basically need to write out a couple different more live data objects with the goal of basically covering all of the different widgets and control operations, control logic, which our view will need to implement or listen to, essentially. Okay, so what this particular thing is going to look like is we're going to type internal val auth attempt. So the reason why we're using internal is I basically want these things to be visible by anything within this particular module. So for example, our fragments. But just for better encapsulation, we're making it invisible outside of any other context. So anyways, we've got internal val auth attempt, and then that's going to equal mutable live data again. Now for the type here, we're going to use unit. So why exactly would I use unit? This is very similar to like void in Java. Not exactly the same, but quite similar. In fact, it does get mapped to void in when it's decompiled into Java. Anyways, how this thing basically works is I suggest using unit when you want to trigger some kind of event, but you don't actually care about any particular value being passed into that event. So what I think I'll do is I'll just show you really quickly what this looks like in the view. So if I look at authAttempt here, just notice that we're not actually returning any kind of value. There is kind of an it, which is of type unit, that will get passed in here. But in this particular case, all we want to do is we just want to call a particular function when this particular mutable live data is changed. So we're changing it and triggering the function, but we're not actually changing it to a particular value. Anyways, what I'll do next is I'm just going to hit Control, just put my mouse right there, and then I'm going to hit Control D, which will copy the line. And then we're going to have a second control logic observable here. So this is going to be called start animation. And again, that's just going to return unit, same idea. All right, so we have our two control logic fields here, or observables, or whatever the hell you want to call them. And in case there's any confusion here, the reason why we're doing this is we need some way to call back to the view. So in this way, we can call back to it indirectly. Anyways, we need a couple more mutable live data objects. So in this particular style of building view models, we basically want a live data object to represent every item in the layout that we're dealing with here. So I'm just gonna again open up, let's do Control-Shift-N, and let's see, fragment login. So what I'm saying here is we basically, the way I actually built this thing is I said, okay, for every item in this layout, every widget which changes, we need a mutable live data object to basically represent the value that it will have. So in this particular case, we have this animation drawable here. We have this text view, which basically just displays the current login status. And then we have this auth button down here, which is how we trigger auth events. And this thing's text will change as well. So it follows that we'll need a mutable live data object for each of these things. So what we'll do is, so I'm just going to type UI binding here, because that's basically what we're doing. And then we're going to again use internal val sign in status text. So that'll be for our sign in status text view. And that's going to be a mutable live data object, and it's going to be of type string. Perfect. Now, since even the animation drawable, we're going to be giving it a URL to a particular resource, all of these things are going to be strings. So again, I'm just going to hit Control D twice, like so, and we're just going to update the names here. So the first one is going to be auth button text. And by the way, pick good names for these things. Like, don't do short, ugly names that leave people guessing about what they mean. Then we have the satellite drawable, like so. I could actually probably pick a better name for that one too, to be honest, but that's okay, good enough. All right, so we have our live data objects, and then what we'll do next is we'll get started kind of working with our handleEvent function here. All right, so what we'll do next is we will code our handleEvent function, and that way you'll get to see our sealed class in action, how it actually works. So what we're going to do, so there's a couple different things going on here. What I'm going to do is I'm going to stub out the presentation logic functions, and then we'll kind of implement those towards the end here, but we can actually get started with them. So we're just going to type show loading state, and I'm going to hit Alt-Enter, create function show loading state. And I'm actually just going to leave this to-do function here. This is actually quite a handy function, because if we do end up calling this particular function when we've forgotten to implement it, then we will actually get an error popping up, which is actually what we want. We want to know if this thing has been implemented or not before we ship the application. So anyways, we're actually going to, as I say, we're going to implement these functions a little bit later. What we'll do now is, so this is kind of the main point of using a sealed class, is we can represent a number of different finite states that this sealed class can represent, and that can represent different events in the front end or back end of an application. So I use sealed classes all of the time, and if you're not familiar with them, you probably should be if you're writing Kotlin. So What we're going to do is we're going to use a when matcher. So we're saying when event, which is what is passed in here. Then we'll give it some curly brackets. And then this is where we list out our different cases. So this is quite like a switch statement in Java and C# and those sorts of things. So we're going to type is login event dot onStart. So we're basically just going to make a function for each of these objects here and the data class as well. And then we do an arrow sign thingy. And then what we're going to do is we're going to type getUser. So we'll need to code this function out. And what I'd like to do first is I'm just going to hit Alt-Enter again, create function getUser. And then we'll just finish off this particular handleEvent function before we get to that. So we have two other cases. So again, I'm just going to hit Control-D, just speed things up a little bit. This one's going to be onAuthButtonClick. And in that case, we're going to type onAuthButtonClick. And again, click on that, hit Alt-Enter, create function, cool. And then for our last event here, we have onGoogle sign-in result. So in this particular case, we're going to type in the onSign-in result. And then how do we actually get data out of our sealed class here? So what we can do in this particular case is we type onSign-in result. And then by saying this is clause here, this actually will cast our event to the onGoogle sign-in result if it does happen to be that particular class. How we get our data out of that is we say event.result, which returns our login result object here. Okay, and that's the property right there. And then again, we'll just hit Alt-Enter, create function. Now this is the function that we're not going to be coding out today. So I'll just make a note here, not coding this one today, but in a later video where we talk about Firebase and coroutines and stuff like that. All right, so that is our handleEvent function. And then what we'll do next is let's go ahead and get started with our getUser function here. So for getUser, we are going to be talking to the repository object up here, repo. And let me just open that up really quickly. Note repository, sorry, this is iUser repository. And just notice that these things, basically, they're all suspend functions. So we're getting into coroutines land. So in order to actually call these suspend functions, we need to basically use some kind of coroutine builder, generally speaking. In this particular case, since we have configured our BaseViewModel to be our root coroutine scope, and our user-view-model extends that, and I do recommend this approach for coroutines. We need to basically make this function into a launch builder. So what we're going to do is we're going to type equals launch, like so. Now it's important to note, if you do not configure the appropriate coroutine scope, just notice that this thing has this coroutine scope thing right here. If you do not configure that properly, things aren't necessarily going to work the same way. You're not necessarily going to be constrained to the appropriate coroutine scope, and I do not recommend you use globalscope.launch. So what we're going to do, it's actually really simple the way I build applications. So we're just going to type val result, which is going to be, we won't specify the type here. We're going to say val result equals repo.get current user. Like so. So if you're wondering what the type is here, we're returning this result wrapper. So this is a result wrapper that I've written myself. There's a couple different libraries and stuff like that you can use. I'll just open it up really quickly, result. And it just basically represents a value, so like a success case, and then it represents an error, so like an error case, big surprise there. And then the way that we actually use it is with this handy build function. So anyways, that's what we're going to be returning. But more specifically, it's going to return either an exception or a nullable user object. So why does it have both exception and then a nullable user? Well, the reason for this is that we might end up checking our Firebase auth for the current user, and there's no current user. So in that case, we would return null. This isn't necessarily an error case. Maybe the user just hasn't logged in yet. So I'm trying to be a little bit more specific. If there's an actual error occurring, then I want that to basically be a different path that the event stream takes. So anyways, what we're going to do is we're going to hop back to user view model. So how I like to use these result wrappers is, again, we're going to use a when matcher. So when result is, oops, not OS, result.value, like so. Then in that particular case, we have a block going on here. So there's a couple things we need to do here. If we actually get a user object from our repo, the first thing we want to do, whether it's null or not, is we want to say user state.value. So this is the value of our user state object here, and this is how mutable LiveData works. So we can say user state.value equals result.value. So what we're doing is we're taking the value out of our result, obviously, and then we're just assigning it to our mutable LiveData object. So that fixes up our the state of the view model here, but of course we're still going to need to update everything else appropriately. So in particular, we need to update our UI binding. So how we're going to do that is we're going to basically represent the user interface with a couple of different finite sort of states. So what we'll do is we're going to write out all of those one after another. I'm just going to actually stub them out first off. So what we're going to do is we're going to hit enter again. So the first thing I want to know is this thing a null value, which again isn't necessarily an error case. And if it's a null value, that means the user is currently signed out. So we're going to type show signed out state, like so. Then we're just, again, going to hit Alt-Enter, stub that function out. And then we'll add an else case. So we're going to say else show signed in state. There we go. Just stub that bad boy out. Awesome. So the only other thing we need to do here is we need to handle our error case. So we're going to say is result.error. If that's the case, then we want to show error state. Cool. All right, there we go. And as you can see here, we have all of our different UI state functions coded out. Okay, so we're still not ready to implement these particular functions yet. What we'll do first is we'll implement our onAuthButtonClick function. So basically what this is going to look like is we're going to type if user state.value, which is our mutable LiveData object, equals null, which means that the user is not logged in, then we want to call authAttempt.value equals unit. So what that's going to do is it's going to trigger the authAttempt observable in our login view here. What that's going to do is that's going to call the start sign-in flow function down below here. And this basically prepares the application to open up basically a new sort of activity using onActivityResult. And what's going to happen is the user can basically choose to sign in with their Google account. And then once that process is ready, then that result will be propagated to onActivityResult when the activity returns. So anyways, going back to the view model, that's what we're going to trigger here. So if user state value is null, the user is currently logged out, and they have pressed this particular button here, except it would say sign in, for example. And that starts our sign in process. Now, if the user if the user value is not null, then that means the user is currently logged in and they want to basically log out. So in that case, we're going to call sign out user. And let's just code that function out. So once again, in order to actually sign the user out, we need to talk to the repository object, which means once again, we're going to be dealing with our suspend functions. So we can go ahead and make that into a launch coroutine builder, like so. Just get rid of that there. And so what this thing is going to look like is very similar to getUser. We're going to type val result equals repo.sign_out current user. And then we're going to use our when matcher. So when result is result.value do something. So in this particular case, what we're going to do is we're going to type user state.value equals null. So in this case, we're not actually returning a value. We just want to know if the user was successfully signed out or not. If they were successfully signed out, then we just want to make sure that the view model reflects that. So we type user state.value equals null, and then we're going to again call our show signed out state function. Cool. Then we'll handle our error case is result.error. And then again, we're just going to call show error state, as you can see there. So that's it for the different control logic functions that we're going to be coding out today. There is, of course, the on Google sign-in result, but as I said several times, we're going to cover that in a different video. The last thing we need to do is we need to actually code out our different states here. So I'm actually going to select all of this, hit Control X, and I'm going to bring it up top to just below our view model objects here. And then we'll get started. All right, it's time to code out our presentation logic functions. Now, before we do that, I just want to show you really quickly, I have this file in the common package called constants.kt. So what we have here are a whole bunch of const val references. So these are compile time constants, which means that they're very efficient. Now, if you need to localize your application for different localizations, then probably you would want to go with strings.xml. In this particular case, this is me just being super lazy and efficient and just typing out different strings, which ultimately will be rendered on our UI here, just in an easily accessible file. So what we'll do is, instead of sort of hard coding these different values, we're going to refer to each appropriate constant, and that'll just, as you'll see in a moment, make our presentation logic a little bit easier to write and a little bit harder to screw up. So the first thing we'll do is we'll work with our error state here. So in this particular case, we're going to say sign in status text.value. So again, we're updating the value of our LiveData object. So the first one's going to be login error. And then the next one, so pretty much how this is going to work is I'm just going to hit Control D twice, and we're going to update these values. So this one's going to be authButtonText.value. And so when there's an error, we want the user to be able to sign in again. So that one's going to be sign in. And then for the next one, we have the satellite drawable, which is like the animation right here. So if there's an error, then we want to basically show antenna empty. So that's a URL to a particular drawable. It's actually this one here, the empty antenna animation here. All right, so once we have that figured out, and let me just double check to make sure I didn't screw anything up. Looks okay, good enough for now. Good genau. Anyways, so I'm going to hit Control C, and I'm just going to paste this into each of these functions since this won't change too much. Again, this is the kind of work that you really need to test, because when you're doing this kind of copy-paste crap, you almost always screw something up. All right, so show signed in state is what we'll be working with next. So when the user is signed in, we want the sign in status to say signed in. We want our auth button to basically say sign out. And then for our antenna drawable, we want it to say antenna full, which is basically this drawable here, except with the wavy things on top. Just deploy the application if you want to see what it looks like. Okay, so we've got our state here. So show signed in state, signed in, sign out, antenna full. That's looking good. Next we'll go to show signed out state. So it's basically going to mirror this one here. So for show signed out state, we're going to say signed out up here. And this one is going to say show signed in state. So this one's going to say sign in. That's correct. And then this one's going to be antenna empty. That's actually correct. It's quite similar to our error state, as you can see. All right, so for show loading state, it's actually going to be much simpler. So we're just going to type sign in status text, and we're going to set that one to loading. Oops, kind of need an equals sign in there. Okay, and then all we're going to do is we're going to call our start animation function here, value equals unit. So earlier on, you may have noticed in the view, if you watched it previously, what we ended up doing is we actually set the animation drawable in the view. So the reason why we're doing that and not actually updating the particular drawable in this case is if we hop into login view, notice that I actually specified explicitly that before we animate our drawable, it must be assigned to our antenna loop drawable. So the reason for this is that antenna loop is actually like the only drawable which is actually an animation list, and I don't want to have a situation where I'm, say for example, assigning just a regular SVG drawable, and then somehow accidentally I forgot to change that to the actual animation drawable, and then we are starting an animation drawable which isn't actually an animation drawable. So basically what we're saying here is this is a little place where I actually did include a little bit of presentation logic in the view, but this is for the sake of avoiding problems with shared mutable state. Alright, so there you have it. I've showed you how to code a simple fragment and how to code a simple view model. And then what we'll be doing in the next video is I'm going to talk about kind of putting all these things together plus a recycler view to make a list feature which is properly decoupled, properly applies separation of concerns. So thank you so much for watching. If you enjoyed the video, please do me a favor, hit the like button down below. Consider picking up my course on Kotlin if you want like an in-detail explanation of a lot of the stuff I covered today, like sealed classes, abstract classes, extension functions, that kind of stuff. And most of all, thank you for watching. Peace out.